In this video, we're going to be discussing rotations. If we take a look at the coordinate plane here, rotation is shown, and if we were asked to describe what a rotation is, we could say it's turning a figure. And if we take a look here, it says, how many degrees do you think the pre-image has been rotated? And the hint is that these answers are usually in multiples of 90. So 90, 180, 270 are the three common degree measurements that we're going to see for rotations. In this case, this is an example of a 180 degree rotation. This might be the easiest of the three to identify because 180 degrees is kind of like the shape or the figure being upside down. And we can see that it looks like this has been rotated upside down. Okay. Another way to decide if it was 180 degrees, assuming the rotation is about the origin, which we're going to talk about in this video, is you can look at how many quadrants it moved. So if I start at A, for instance, it moved 2 quadrants over. 2 times 90 is 180 degrees. And it asks a 90-degree rotation counterclockwise is equivalent to how many degrees clockwise, and that answer would be 270. And we're going to take a look at that in just a minute as well. Okay. All right, so for the remainder of our notes here, 5, 4 is plotted on each coordinate plane, and we're going to turn our paper. I'm going to do a little turning on my iPad here according to the number of degrees and the direction. We're going to find A prime, and then we're going to generalize a shortcut rule for each rotation so that if you prefer not rotating your paper, that you can still figure out the coordinates of the image after a given rotation. So notice for each of the 3 columns here, there are 2 different ways that this rotation could be identified. The first is rotation 90 degrees counterclockwise about the origin, and the other is 270 clockwise. So the way that we can determine if these 2 rotations are equivalent is if there's 2 different directions, so one is counterclockwise, one's clockwise, and if the 2 values add up to 360. So 90 and 270 add up to 360. In the second column, 180 and 180 add up to 360, and then in the third column, you have 270 and 90 just reversed. Okay. So what we're going to do is we're going to rotate our paper. Like I said, I'm going to do some rotating on my iPad to determine what the coordinates of A prime are after each of these rotations. So when we are doing a counterclockwise rotation, we are going to be turning left. And when we do clockwise, we're going to be turning right. And if you're unsure like why that is, if you think about a clock, I'll just draw part of it here. And if I have 12, the numbers when we read the clock are going to the right. Okay, so starting at the 12, right, our day starts at 12, the numbers on the clock go to the right, so that's clockwise. The numbers do not go to the left, so that's why we call it counterclockwise. That prefix counter means opposite, like a counter example, for instance. So we're going to be turning our paper 90 degrees counterclockwise, so once to the left. So 90 degrees is always going to be 1 turn, 180 is going to be 2 turns, and 270 is going to be 3 turns. Similar to like how I showed before that 180 degrees moves 2 quadrants over. So what I did in order to show you this on my iPad here is I have just an image of that graph, and I'm going to rotate it 90 degrees counterclockwise. So that means I'm going to take this figure and I'm going to move it once to the left. Okay. So if I go back to normal for a second, again, I took my graph, I moved it once to the left, so it looks like this. Now, when I hold it this way, it almost looks like the x-axis is now here and the y-axis is now here, right? It's like they flipped. And if you look at the coordinates of where that point is, the point that we started with, A, it now looks like it's -4, +5. Right? So this point, -4, 5. That's what it now looks like. Okay. So I'm going to go back to my list here, and where it says A becomes 5, 4, I'm going to put in what it now looks like, which is negative 4, 5. And I'll plot that on the graph here too. And if we want to come up with a shortcut rule here, notice the coordinates swapped, but what was the y coordinate now became negated. So it's negative y, comma, x. You'll notice in the picture here that we moved one quadrant to the left, so that indicates our 90 degrees counterclockwise rotation. Now, if I go back to that picture where I was demoing before and I erase everything, okay, and let's say I rotate it back to the way it was, if I wanted to show 270 degrees clockwise, I would take this picture and I would rotate it 3 times, because 3 times 90 is 270, 3 times to the right. So I'd go once, twice, 3 times, and you can see that it looks just the way it did before when we did one turn to the left. That's why those 2 rotations are equivalent. All right, now that we know how to turn our paper, we can go through the next one a little bit quicker. We're asked to find rotation of 180 degrees, and that either way is going to be the same, whether it's clockwise or counterclockwise, because essentially I have to take my graph and I have to turn it upside down. So I'm going to take my graph here, and I'm going to do 2 turns. And now I'm going to basically reinterpret what my axes are. So if I take a look at this point A, it does not look like 5, 4 anymore because my graph is upside down. So I have to think about, what does it now look like instead? So it looks like I have the point negative 5, negative 4. And that's going to be the coordinates of our image after a rotation of 180 degrees. Okay, so I'm going to go to my column here. 5, 4 became negative 5, negative 4. I can go and plot this on this graph as well. And what happened to the coordinates? They were negated. So xy becomes negative x, negative y. Okay. All right, I'm going to reset my graph here to show you the third example. And now we're asked for 270 degrees counterclockwise. So that means I'm going to be turning my figure 3 times to the left. And I'm going to go ahead and do that, and we're going to see what does A prime look like. So here's 1 turn, right? That's our 90-degree rotation. Here's 2 turns. That's 180 degrees. And I'm going to go 1 more time around in order to get my 270-degree rotation. So now let's take a look at what this point looks like. Again, it looks like this is my x-axis and this is my y-axis. It looks like it's been reversed. And that point looks like it's 4, negative 5. Okay. And keep in mind, in order to do this method, you do have to have the pre-image plotted first so that you can now read the axes. So my point 5, 4 became 4, negative 5. So let's talk about what happened. The 2 values were swapped, and what was the x coordinate got negated. So xy becomes y, negative x. Okay. These 3 shortcut rules here, so rotation of 90 counterclockwise, rotation of 180, and rotation 270 counterclockwise, are really helpful so that if you don't have graph paper or you don't want to turn your paper, that you could actually find the coordinates of the image still. Okay, so I'm going to show you exactly what that would look like. So if I look at sample question number 1, it says, what are the coordinates of A prime? 8, negative 1 is A, after a rotation of 270 about the origin. So if I apply that shortcut rule, which was negating the x value and then swapping the 2 coordinates, I can get my answer of negative 1, negative 8. Now, of course, if I wanted to have plotted it and I wanted to turn my paper 3 times to the left, I certainly can. We're going to assume if it doesn't say that it's counterclockwise, by the way. I'll show you how you would know clockwise in a little bit. And if I just wanted to check this a little bit, if I do negative 1, negative 8, A prime here, I can see that I moved 1, 2, 3, quadrants in a counterclockwise direction, so therefore 270 counterclockwise. All right, for the rest of these, I'm going to do them using the shortcut rule. So for 2, -5, 9 becomes +5, -9. We are going to negate our values when we do a rotation of 180 degrees. And I will show you the check here that if I plot A and if I plot A prime, I did move 2 quadrants over in a counterclockwise direction. For number 3, here's how you're going to know, unless it says the word clockwise, of course, but here's how you know clockwise. Anytime you see that the angle measure is negative, that's going to indicate reverse the normal way you do this, and in this case, do a clockwise rotation. So this, keep in mind, is the same as 270 clockwise or 90 degrees counterclockwise. So the point 0,4, okay, so the point 0,4 would then have the y value negated, and they would swap coordinates, swap spots. So I'd get -40 using that rule, okay? So if I want to plot and do the check, A is 0,4, A prime is -40, and it looks like it moved 1 quadrant to the left, so that's 90 degrees counterclockwise, or 1, 2, 3 quadrants to the right, that's that -270 or that 270 degrees clockwise. Notice that the 90 degrees counterclockwise and the 270 clockwise make a full circle, and that's where we get 360 degrees from. All right, for number 4, we're going to plot the image of rectangle JKLM after a rotation of 90 degrees about the origin. So I'm just going to quickly jot down what those points are in the pre-image first. So it looks like that J is 5, 6. So I know then that J prime, we're going to negate the y value and switch. That gives me -6, +5, and I'm going to plot that. If I look at K, K is 8, 6. If I negate the y value and switch, I get -6, 8. If I look at L, L was 8, -2. Following the rotation rule, I'm going to negate the y value and switch. So that gives me 2, 8. As L prime, and for my last one, M is 5, -2, negate the y value, then switch, and I get 2, 5. Once I have all 4 points, always label them with the prime symbols so you know image versus pre-image, and I'm just going to connect them to form the completed rectangle of the image. Keep in mind that rotations, are rigid motions, just like reflections are, and translations. And that means that the pre-image and image are congruent to one another, which we can see in this case. All right, for our last set of questions that we're going to see here, we're going to talk about, well, what does it mean when we don't rotate about the origin? So all of those problems we saw so far are rotated about the origin. The origin is a fixed point that does not move. If you even think about any of these rules that we looked at before, if you apply any of them to the origin 0, 0, it's not going to change. It doesn't matter if you flip the coordinates or negate them, you will get 0, 0. So the center of rotation is a fixed point. It does not change. It's the center of which you're rotating, okay? If you think about, for instance, a clock, right? If I have a clock here, there's this center point here where the hands are kind of like pinned to the clock. That's where the hands are spinning around, okay? If you think about a windmill, a wheel, anything that rotates, there's always this center of rotation, okay? But sometimes when we were working on the coordinate plane, the center is not the origin, and these problems can be a little bit more difficult. So off to the left here are the steps of how you could do it. There are other ways. This is just one method. Redraw the axes using the center as the origin. determine the coordinates of the pre-image using the new axes, apply the rotation rule, and then we're going to determine the coordinates of the image using the original axes. So just take note when you're doing these, new axes versus original axes. That's going to be important. All right, so let's look at number 5. Find A prime, the image of A, after a rotation of 180 degrees about -2, 1. So what I would absolutely do to start is plot that center. So I'm going to plot the point -2, 1. Okay. So normally remember that the center of rotation is the origin. Now it's this point -2, 1. So the way that I'm going to do this is I'm going to draw in new axes. Okay, it might help to do these in a different color than black so that it stands out on the page. And I'm going to pretend that this point, -2, 1, is the origin. Okay, so if I look at my steps here, I did the first step. I redrew the axes using the center as the origin. Then it says determine the coordinates of the pre-image using the new axes. Okay, so ignore the original axes, and I'll even write this in here so that you guys can see. I'll just write some of these. I'm not going to fill in all of the numbers. But I'm pretending that that point is 0, 0 for a second. And I'm just kind of jotting in, well, what are the values on the axes? Okay. You don't have to fill in all of the values. I'm just filling in a few here so we get the idea. Okay. So when I look at my new axes, the point A actually looks like it's 5, 1, right? We know that it's not, right, if you look at your original axes, but it looks like 5, 1. And that's what our second step said to do. Determine the coordinates of the pre-image using the new axes. So step 2 is done. Step 3, apply the rotation rule to get the image coordinates. So rotation of 180 degrees, that rule was negate both. So that would make this point -5, -1. If I plot that point, -5, -1, it would be here. Okay, so I'm plotting A prime there. So what I'm going to do, and this might be a little bit easier to just watch on the iPad for a second here, is I'm going to actually erase all of our new pretend axes. And I'm going to look where A prime is. Because our last step, and we did step 3, by the way, our last step is determine the coordinates of the image using the original axes. So if I take a look at this point here, this point looks like it's -7, 0, and that's going to be our answer to this question. Okay. So those two, I'll put the center back in there. Point A was rotated 180 degrees about -2, 1. That gave us an answer of -7, 0. Remember, this work over here is just like our scratch work to help us find using the point using the new axes. Okay. All right, let's try one more of those, but we're going to do it with a few points in this case. So before we get started, I'm just going to jot down what the coordinates of A, B, and C are. So it looks like in this case, A is -3, 5. B is 4, 3. And point C is -3, 3. Okay, so now it says plot triangle A prime, B prime, C prime, the image of triangle ABC after a rotation of 90 degrees about C. So anytime you are using a point from the shape as the center of rotation, that point, remember, is a fixed point. It doesn't move. So I actually know C prime is going to end up being right on top of C. Okay, it's not going to change. That's our center though, so I'm going to repeat the steps from before. So step 1, draw in your new axes, making the center of rotation the center of those axes. And now we're going to reinterpret our coordinates here. So A happens to look like, so over here's my scratch work. Here's my work for A. A looks like the point 0, 2 using those new axes. So C is 0, 0, right, on our new axes. It's 2 above that, so 0, 2. If I apply the rotation rule, 90 degrees, we're going to negate Y, then switch. That gives me negative 2, 0, and I'm going to plot that on here. So negative 2, 0 using my new axes. B, if I take a look at my new axes, looks like 1, 2, 3, 4, 5, 6, 7, 0. If I apply the rotation of 90 degrees, negate y, then switch, I get 0, 7. And I'm going to plot that using my new axes. Now in this example, since C is the center of rotation, it is not going to move, but we could try it if we wanted. If we look at C on our new axes, it looks like 0, 0. If I apply the rotation of 90-degree rule to it, I'm going to just get 0, 0 back. And so C prime stays exactly where it was. So I'm going to now connect A prime, B prime, and C prime. I'll actually remove these axes in here and just connect the shape. And we can see now that triangle ABC has been rotated 90 degrees. Here's our 90-degree rotation, and it's been rotated about point C. That is our fixed point that we are spinning around, and it didn't change coordinates. Hopefully this video helped you understand rotation centered at the origin and rotations not centered at the origin.